Welcome back to The Explainer. Today, we're going on a bit of an expedition. We're going to pull back the curtain on the hidden world of technology that powers, well, pretty much everything around us. We're going to map out the entire universe of embedded systems, and we'll be using the incredible open-source lab PiEmbSysTech as our guide.
So, just think about that for a second. Your car, a kitchen appliance, and a little device you wear on your wrist. They seem worlds apart, right? But they all share this amazing secret. Deep inside, they're all run by tiny, specialized, hidden computers.
And that's exactly what we're talking about. This is the world of embedded systems. It's a whole universe of these tiny but powerful computers, each one designed to do one job and do it perfectly. Whether that's heating your lunch or tracking your steps, they are the invisible intelligence that makes our modern world tick.
Okay, so let's dive right in. The best way to get your head around this is with an analogy. Imagine you're building a smart device, but think of it like you're creating a creature. And what's the very first thing any creature needs? It needs a brain.
So right away, an engineer faces a huge choice. What kind of brain? On one side, you have the microcontroller, the MCU. You can think of this as a complete, self-contained brain. It's got memory, it's got everything it needs all on one tiny chip. It's perfect for a simple, repetitive job, like telling a smart light bulb when to turn on. But on the other side, you've got the much more powerful microprocessor, the MPU. This is more like just the core of a brain, the CPU. It needs a bunch of external parts to work, but that's what makes it the powerhouse inside complex things like your phone.
And you know, just like in nature, specialization is absolutely key. The main brain can't be an expert at everything. That's why you have these coprocessors, these XPUs. They're like specialized parts of the brain that handle one job incredibly well. A GPU, for instance, lives and breathes graphics. An NPU is built from the ground up just for AI. By handing off these tough jobs, the main brain can focus, and the whole system just runs way faster and more efficiently.
Of course, a brain is really just a hunk of silicon without a mind, right? It needs a way to think. So once you've picked the hardware, you've got to give it instructions. And that's where software, operating systems, and programming languages come into the picture.
These little devices, they think in code. And in their world, a few languages are king. C and C++, they are the undisputed workhorses. They give engineers that direct, down-to-the-metal control you need for raw performance. But then you have modern languages like Rust, which is amazing because it's designed with safety as its absolute top priority. And you even see Python used for more complex, high-level stuff, especially in the world of robotics.
So how do these systems actually manage everything they have to do? Well, for a lot of critical jobs, a normal computer OS just isn't going to cut it. They need a special kind of nervous system, a real-time operating system, or RTOS. And here's the crucial part. An RTOS isn't about being fast, it's about being predictable. It guarantees a response within a very specific time frame. Think about a car's airbag system. You can't have lag. It has to fire right now, without fail, every single time.
And wow, is there a huge world of these things. You've got fantastic open-source options like FreeRTOS and Zephyr that developers absolutely love. And then you have these bulletproof commercial systems like QNX that are certified for the most critical jobs you can imagine, in cars, in airplanes, in medical devices.
Okay, so let's keep building our creature. It has a brain and it has a mind. But for it to be useful, it needs a voice and ears. It has to be able to talk to other parts of the system and to us out in the real world.
And what's fascinating is that different environments require totally different languages. I mean, take a modern car. It's basically a computer network on wheels. The really important stuff, the engine, the brakes, they need a super reliable, lightning-fast network, so they speak a language called CAN. But for simpler things like your power windows, a cheaper, less complex protocol like LIN works just fine. It's all about using the right language for the right conversation.
Now let's jump from the car into your home. The protocols here are all about convenience and connecting everything together. You've got Wi-Fi, obviously, for streaming tons of data. You've got Bluetooth for all your personal gadgets. And then you have these cool, low-power networks like Z-Wave and Thread, which are the reason your smart sensors can run for years on a single tiny battery.
And just to really drive the point home, compare all that to a factory. Here, the priorities are completely different. It's all about being tough, being super precise, and being safe enough to control massive machinery. So you see protocols like EtherCAT, which is designed for insane, high-speed, real-time control to make sure every single piece of a machine works in perfect, safe sync.
So you see what's happening, right?
When you start to combine these three layers, the right brain, the right mind, and the right way of talking, that's when the real magic happens. That's how you get the incredible technologies that are literally reshaping our world.
This is what it's all for. This is the why it matters part. This fusion of hardware and software, this is what makes the Internet of Things possible. It's what's powering the next wave of advanced robotics, and it's the very foundation for the amazing safety features and self-driving tech that are showing up in our cars today.
But at the heart of all this crazy innovation, it's people. It's this massive global community of engineers, students, and makers who are building this future. And to do that, they need access to great resources. That's why open source projects like the PiEmbSysTech Lab are so critical. They're literally giving the tools and the knowledge to millions of people so they can learn, create, and push this technology forward.
And honestly, the mission behind this incredible open source resource says it all. It's about empowerment. It's about bridging that really tough gap between learning the theory in a textbook and actually getting your hands dirty and solving a real-world problem.
And that kind of brings us to our final thought for today. We've mapped out this invisible world of computers that's all around us. But understanding how it all works, that's just the beginning. The real question is, as this technology gets woven ever deeper into the fabric of our lives, what are the incredible things we should be excited for, and what are the new challenges we need to start thinking about?